Hello friends, this is Durga again from Technology Mentor slash IT Varsity, and as of now we are talking about MapReduce, yeah, particularly yarn. After we have seen how to set up, how to provision nodes from AWS as well as create virtual machines on our PC, and then we have seen how to set up Ambari, HDFS, etc. And we are talking about data processing in Hadoop, and we have two frameworks which uses MapReduce internally, and they are classic as well as MRV2 plus yarn. We are almost done with the setting up uh, yarn plus MRV2 component after classic, and now we will get into the details about changing the behavior of your jobs while at the runtime before submitting the jobs. So for that, I'm using my AWS cluster for demonstration. I have already started my cluster, and here this is my Ambari for it. No, not this one. I'm sorry. Where is the Ambari? Yeah, here. So this is my cluster on AWS, and it has HDFS, MapReduce, 2YARN, Zookeeper, and Ambari matrix. So now before trying to run the jobs, I would like to enable SSH tunneling so that we can actually access logs and see the details of jobs later. So it's a two-step process, as you already aware, SSH tunneling or Foxy proxy. First, we have to start uh, SSH command with minus capital N minus D and port number 8157, and that port is defined in Foxy proxy settings.xml file which we have created while setting up Foxy proxy. So let me grab that command from the history. This is the command which you need to use. The major difference is this one. Other than that, rest of the command is same. Hit enter and it will hang. That means SSH tunneling is going on. If it comes out of it, then it will be stopped. Now you have to go to the browser. We are using Chrome for SSH tunneling, so I have to open Chrome, and here you have to enable um, appropriate proxy, which is also valid. In our case, for the AWS, we are using this proxy. Enable it, and to test whether it is working, you can just do www.google.com, and if the page comes back without any issues, that means your Foxy proxy is working or SSH tunneling is working. That being said, let us go back to the command prompt again, and let us try to connect to the to our gateway node. So if you look at our cluster, we have 6 hosts, and the first one, if you check the components, it does not have any daemon process like name node, data node, or yarn related like resource manager, node manager, anything. It just have all the clients installed on them on top of Ambari server, which is not visible here. So it's a gateway node which simulates the true production setup, and using that we will try to run MapReduce job, and we will see how we can change configuration parameters at runtime while running it. Okay, so first let me run without changing any configuration. So I'm connecting, uh, I'm copying the jar file, training.jar file, to the cluster. So this is the command which I'm using. I'm using pem file to connect to the cluster, and then this is this file on my local file system on my Mac, trying to copy it to this username and host combination, and tilde represents the home directory of EC2 user, which is /user/EC2 user, and the file will be copied in a moment. Now the file is copied, and I'm actually doing SSH to that host, and now I am in the host, and let me I have already copied large.txt file. Let me run hdfs fsck command on that file. User ec2 minus user large deck.txt minus files minus blocks minus locations, and confirm the replication factor on this. So the replication factor is 2 for this. So let me uh, change the replication factor. There are multiple ways to do that. You can delete the file and you can change it, or you can actually run Hadoop fs. There is a command called setrep. So Hadoop fs set rep, and I want to set it to 1, and the path is user ec2 minus user large deck.txt. Now it is set to 1, but it will not change immediately. It will take time, because the balancer, which is the additional daemon process that will be running behind the scenes, have to run to change the replication to change it. So at times it might run immediately, and at times it might take little time. In this case it ran immediately. Yeah, in this case it ran immediately, I think. That's why you see only one block, one copy of the block for this file. So it's a 350 MB file, as you have already seen. Now let us run Hadoop jar command to get card count by suite. So I try to delete output directory because I am using that directory name while running the command, and here I am trying to run this card count by suite program, which is part of training.jar file. And as you have seen in my previous videos, you already know that this class is already existing. So I'm running on that program on this input path, which is user ec2 user large.txt, and this is the output path for this program. So that directory will be created at runtime. So once you type this Hadoop jar command, hit enter, and I would like you guys to focus on two things. One is number of splits, which is 3. So I will talk about split size also as part of this video, and the other one is the replication factor on this file, on the directory. Most likely it will be 3, because the default replication factor is 3 at our cluster level. So we will see those two things we will try to manipulate while running the job next time. There are several ways to do that. You can actually pass individual configuration parameters set that as part of Hadoop jar command, or you can have all the configuration files, all the configuration parameters which you want to override, or even the new one, and new ones which are defined by the developers into a XML file, and you can pass that XML file as a parameter as well. So now the program is done, and I don't want to go and see what are the contents of the file. I just want to validate what is the replication factor of my directory output. Files, blocks, locations, hit enter, and you can see that replication factor is 3. So there are two files, one is 0000, other one is 00001, but the file size is very small. One is 14 bytes, other one is 43 bytes, and you can see that it exists on all the 3 nodes, 14, 15 and 16. Similar is the case with 00001 as well. Okay, now let us talk about split size before running it again next time with the custom size. So as we have seen, it has created 3 mappers. If you go to this, as we have already enabled tunneling, you can actually go back to the URL generated by this. Even though using private IP, you can copy this URL, go to your Chrome where your Foxy proxy is enabled, paste this URL. Probably Foxy proxy, yeah. So see, the Foxy proxy or SSH tunneling is um, broken here. That's why that link is not working. So if any of the links are that are using private IPs are not working, first thing you need to check is whether SSH tunneling is still going or not. Now if you hit enter, you can see the what is going on using the console using the URL of the job. Okay, and if you see the job, there are 3 mappers created for this. And if you go back to the picture which I have explained earlier, the file have 3 blocks, so there are 3 mappers created typically. And what is this and this number of mappers is not driven by block size, it is driven by something else called split size, and we'll talk about split size now. So to check the current split size, you can go and start typing split as part of the configuration. Click on this configuration link here and then search for split. So there are two this is the main parameter which will actually control the number of mappers that will be created while the job is running. So by default split size is 0, which means it will take the block size in effect. So if you want, you can increase the split size to the higher value than block size typically, and the number of mappers that will be created for that job will be lower. So the purpose of giving additional parameter like split size is, let's take the example of a 3 GB file. In this case, right now we have only 300 MB file, and in the 300 MB file, let's take the example of 3 GB file, and what will happen is there will be approximately 24 blocks, and those 24 blocks will be distributed on all the 3 nodes, on average 8 blocks on each of them. And if you have enough memory, instead of having one mapper for each block and spawning 24 mappers to process the data, as you have larger amount of data, means multiple blocks of the given file on each of the node, you can safely increase the split size to 512 MB or 1 GB, and you can actually run the job with increased split size. Now fewer mappers will be processing the data even though you have 24 blocks. So in this case, there will be, if the split size is 512 MB and block size is 128 GB on a 3 GB file on a 3 node cluster, then instead of spawning 24 mappers, it will only spawn 6 mappers. So those 6 mappers will process the data mostly using data locality. So that is the reason why this additional parameter of split size is provided. It is the lowest granularity at which mapper will process the data, and by default it's 0, which means it is equivalent to block size. And there are some additional things also which you need to keep in mind when it comes to split size. It can be smaller than block size, but if developers uses combined input formats, or even the third-party vendors, if they use combined input formats, split size can be smaller than block size also. So you can have 124 MB block size and 64 MB split size. And if you want to give more horsepower to process the data, then decreasing the split size can actually process data faster. Increasing the split size might slow down the job slow down the job in some cases, but it will use the resources more effectively. So even if one job might be slow, the overall usage of the cluster will be far more efficient if you increase the split size. And if the file is smaller than block size or split size, in this case, let's say Instead of uh, let's take the example of this picture again. So let's say that you have three files and each file is around 64 MB. So even and you are trying to process all these three files in one shot using Hadoop jar command. And even though your block size is 128 MB and split size is, let's say, 256 MB, as your file size is smaller than block size as well as split size, still there will be three mappers that will be created. That is in the scenario of multiple files smaller than um, block size. Okay, but in our case we are processing largdeck.txt, which is greater than block size 128 MB. Our file size is 350 MB. So now let us see how we can actually uh, tweak the split size. For that, again, to change the parameters at the runtime before submitting the command, there are two ways to do that. One is by using Hadoop jar file, your optional class name if it is runnable jar, and then you can actually pass your parameters using -d. Give whatever parameter you want, like dfs dot replication equal to 1, and then you can give input path and output path. So now let us run the actual command with -d. So now I'm running this command with -d dfs dot replication. I'm not using the split size yet. We will see that in the next time when we run it. We will use a different way of running this command. So when you run this, previously if you see, the replication factor of these blocks that are generated which are under output is 3. Now we are changing it to 1 before running the job at runtime. Hit enter. It will take few moments. You can see that it is taking 3 splits, means there will be 3 mappers for this job. So this is the informational line where it is saying about number of splits being used for this job. Now the job is completed. Now let us run the hdfs fsck command on output 01, which is the directory that is passed as output path while running the job with dfs replication as 1. And you can see that replication factor is 1 for both the files here, and there is only one copy of them. Now let us see the another way of doing it. Instead of using -d, you can use something called -conf and pass a configuration file, and that configuration file can have all the parameters. So I have already generated the configuration file. I will show you the content of it. The configuration file should start with configuration tag, and then for each property you need to have the property tag. In this example, I am trying to set dfs.replication to 1 and also min size to 256 MB, and I am closing the configuration here. So you can have as many configuration parameters as you want at runtime, not only predefined but also user defined. At times developers will create custom configuration parameters, and they might want to change at runtime as well. So those also can be added to this, and those will be used as part of their programs. So developers have to give certain instructions to administrators if they want to override those parameters. But administrators needs to be aware of these things, especially the split size and also the compression, those things, so that if they think that making certain changes to a very long running jobs at runtime can improve the performance, they can play around it, and they can suggest the developers to make the necessary changes. So that's how it works. That being said, let me run that command. So here the command look exactly same: Hadoop jar file name, class name, and only difference is this part where we are saying -conf and conf.xml. In this case I am using a relative path, so the conf.xml should be there in the current directory, or you can use the absolute path also. and this is the input path, user ec2 user largedeck.txt, and this is the output path which I'm trying to use, which is a new directory. Hit enter, and while it is running, if SSH tunneling is still going fine, we can copy this URL. So in a long running job, you need not wait until the last minute to see whether your parameters are in effect or not. You should go ahead and validate those things immediately. Okay, you can click on job, you can click on configuration, and here you can see dfs.replication as 1, and also split size as 256 MB. Okay, so both the parameters which we try to customize at runtime using conf are in effect, and you can see that number of splits are only 2 now instead of 3 when it compared to the previous runs. Okay, because we have increased it to 256 MB and our file is 350 MB, so one mapper have processed two blocks, and the second mapper have processed the third block. So you can actually have a look at those details also. Click on overview for that, and then click on this link, maps that are successful, and then you can click on this, which took 44 seconds. Somewhere it will give the information about the blocks it have processed, probably in the logs. This will give the full log. Yeah, here it is saying processing split, and this split will might have two blocks mapped to that. So that being said, let us validate again using hdfs fsck command on 02, and make sure that we have only one copy of those two files or blocks, because our replication factor is just 1, and here it is correct. So we have only one copy of these two blocks which are mapped to the files that are generated as output of the job. That being said, that is it about the jobs that are and the split size, and also how to override the parameters at runtime before submitting the job. And also we have seen how to validate the parameters in job.xml, and already I have covered understanding the counters in the previous couple of videos. And here also we have seen the differences in the counters information after running the job. In this case, the launch map tasks are only 2 because our split size is 256 MB. So split size is a very powerful performance tuning tool, because if you have a very large file which have multiple blocks on each of the node, increasing the split size to a reasonable value can actually improve the performance of that job, and also the usage of the resources on the cluster will be far more effective. So make sure you understand the split size thoroughly, and it is a very good performance tuning tool. That being said, I hope you are enjoying the content of my channel so far. If you have not subscribed to my channel yet, please do so. Feel free to post a comment or ask any questions in the comment section of the respective video. If you like the video, please click on the like button. It means a lot to me. Thank you. Bye.